Today we are going to talk about a Hertzsprung-Russell diagram, or HR diagram for short. This diagram is essentially a graph that is used by astronomers to compare stars to each other and see roughly what life cycle stage they are in. So here's what a basic HR diagram looks like. As you can see, we have the absolute magnitude on this axis that determines, or that is the brightness of that star. We have temperature along the top, which is measured in Kelvin. Temperature also helps correspond to the spectral class, which is on the bottom axis. And then we have luminosity over on the side here, which also coincides with the magnitude of a star. This HR diagram has the colors added to it for spectral class. So spectral class and temperature determine what color the star is going to be. So the hottest stars over here on the left-hand side, anything above 25,000 degrees Kelvin is going to be an O star, all the way down to anything that is less than 3,000 degrees Kelvin is going to be an M star. So you can see as the temperature decreases, the color changes from blue to white to yellow to orange and to red. One important thing to keep in mind about an HR diagram is that it is not a star chart. It does not have any relationship with where stars are found in the night sky. It is just basically a comparison tool to see how other stars compare to each other and to look at their characteristics. Let's take a second and look at our sun and how our sun is possibly going to move through this HR diagram as it grows old, as scientists like to say. So here's where our sun currently is. It is a class G star, and it has a luminosity of 1 and a temperature of roughly 6,000 degrees Kelvin. As our sun begins to run out of fuel, it's going to expand and become what is called a red giant. So you can see it has now moved up here to this part of the graph. Once it starts to fully run out of hydrogen and helium, the core of the star gets really dense and it becomes what we call a white dwarf. So it is found in this lower quadrant of the graph. As you can see, it also gets hotter at this stage. Now it is a B class star. There is one stage past a white dwarf, which is called a black dwarf. Black dwarfs are not shown on an HR diagram because once a star becomes a black dwarf, it no longer is emitting any light. So the magnitude is essentially non-existent. So let's take a second and try and practice placing some stars on an HR diagram based off of their basic characteristics. So where would a star with a temperature of 5,500 degree Kelvin and a magnitude of +5 fall on the HR diagram? So this star would fall somewhere here. So that would be a class G star, pretty similar to our sun. It would roughly be a luminosity of a little bit less than 1. And again, it's very similar to our sun. Second practice. Where would a star with a temperature of 24,000 degrees Kelvin and a magnitude of -8 fall on an HR diagram? That star would essentially fall somewhere up here. I hope you have learned how to read an HR diagram and that this was helpful, and thank you for listening.